But just to say a few words about myself, I'm trained as an architect. I have a full professorship at the Royal Danish Academy of Fine Arts School of Architecture. And I have, for the past 12 years, been heading a small research center called Center for Industrialized Architecture. It sounds pretty hardcore. It is. But it's actually, we're trying to dig into the fabrication of architecture from a sustainable point of view and with the eyes of an architect. How can we engage with this? So it's a very close look on technology, building technology, construction, the building industry. But again, from an architect, with an architect's eyes. Then for the past 2 years, I've been co-chairing this candidate program or master's program called SET, in the daily speaking, Settlements, Ecology and Tectonics. And that's a new program that was just invented from the school. But before getting more into that, I'll just say a little bit more than that about myself. No, this is not the computer. I have to use this one. Thank you.
No, you have to...
and which one do I push?
No, you have to sit here or I do it?
Oh, okay. I can go back and forth, or you can do it. But please, change. Talking about sustainability and where do we all come from, I think this was probably, when I present myself, I also, at least to student and colleagues, I always present the fact that I live on a houseboat in the center of Copenhagen, and which we bought in 1989. And I think that over the years it becomes more and more clear to me that this is also, it's really addressing the fact, what does it mean to be close to nature and close to sustainable questions, or questions about the circularity of nature and seasons and everything. And just the fact that we sort of salvaged this old barge from being, how do you say, in Danish we say cut up, to make it into a home has been was a quite a great challenge. But so also from that perspective, that saving something that has a cultural history that links to the city of Copenhagen sort of brings in this dimension, which I think I carry with me on a daily basis on my way to school every day. And this was what it looked like when we took it over, and this is actually what it looks like now. We lived there with three children and a dog, and I'm 5 minutes from school. It's sometimes a little bit, almost too close in terms of getting out of the island, as we usually say. But what's interesting about living like this is also that this question about climate change is moving closer and closer every year, having the fall and winter storms, and having seen that the sea level in the harbor of Copenhagen is actually rising now to very critical levels. So it's just the whole fact of being close to nature, although being in the center of the city is a great, I think it's a great treat, but it's also a great challenge on a daily basis. But please change. This is the KADK, as it's called right now. I think if I had been here 10 years ago, I would probably have called it something like RFDA, FDA, something like that, the Royal Danish Academy of Fine Arts, School of Architecture. In 2014, we had a merger with the School of Design and School of Conservation, and became the KADK. We had a new dean, we had a new structure of the whole way the school was governed. We had a professional board, and we were moved from the Ministry of Culture to the Ministry of Education. All these things happened within a year. It's a very old school. I think it's probably the second oldest architectural education in Europe. It was founded in 1754 by King Frederick V. So in that sense, we those of us who actually studied there and was graduated from there have this sort of, how to say, legacy of history carrying with us all around. But at the same time, it's also a very contemporary school, and it certainly has changed. Please. In 2014, we also then changed the whole structure of the school into, we did have institutes, as they're called, or departments, beforehand, but now because we had these two new schools integrated, they wanted to make what they said a couple of shared programs, not with conservation, because that's a very, very special training or education, but across design and architecture. And just to say that we have 2 architectural schools in Denmark, one in Copenhagen, one in Aarhus, and then we have had, before the merger, 2 schools of design. So now at this moment we have the KADK, which is a conglomerate of educations, a small university, design university, and then the School of Architecture and the School of Design still. What happened was that we got a number of new programs. Everyone had to sort of bid in or propose programs both for bachelor's and for candidate programs. And this whole landscape of new titles came up. And I proposed one which talked about ecology, tectonics, and industrialized architecture. Someone else proposed something about urbanism, ecology, and planning, and then someone found out that, well, the 2 of us should make a program together. So this was just to explain how this whole procedure or this process was taken on. Then at that time we also had some few research centers that were situated in different institutes, and some of them survived, some of them didn't. It very much depended on the head of institutes that were also hired during that same period. So I'd say that in like 2 years ago, a whole new group of people entered the school, both at the management level, but also in among faculty, and all the new programs were initiated. Please. But as for the institute that sort of survived in its old form, we had these were the main titles or the fields across which we were researching and teaching. And before this new structure, we taught courses mainly across different departments, and in this new structure we are now fully integrated, which means that I work more than 24 hours a day, I think, at this moment, because I still have to keep up the research center, and then I'm running this large candidate program. We have almost 1/4 of all the candidate students. We have 80 students across 4th and 5th year. But what happened as far as the topics, the climate and comfort people were taken out and moved into the design institute, which was to me a great puzzle. I don't think you can speak about constructions and architecture without talking about building physics, but all these things happened, and it still hasn't really found its proper form. Please. But this just came up the week before last. What's happening at this moment is that we have, as you may know or may not know, that we have a government that is mainly supported by the right-wing party in Denmark, and they have a very strict policy in terms of having people getting into work, which is reasonable. But at the same time, they are looking at the unemployment rates, and among the most unemployed are designers and architects. So we actually were subject to a budget cut of 38%, which was implemented the week before last. It's 30% of the intake of students and 8% of the total budget. And we were just called for a meeting where the dean was telling us how this was going to be executed. And it also affected, of course, the structure of the programs. So these things are happening just these weeks. And while I've been sitting here, I'm having all these emails ticking in saying something like, "Oh, now we're protesting. Can you sign this protest letter?" And all these things are happening in the background at this moment. But at the same time, by putting us into this new managerial reform among the universities in Denmark, we don't have any democratic influence on the decision making at this moment, which is very, very frustrating from academic point of view. But so far we survived. We survived this new cut down. We're still out here. It says in Danish, but we still hold the title. But it says here we have to be developed further. So this we are very curious about what that implies. And actually what happened, what was very severe is the design school has lost one institute and has actually been minimized to half its size. So they're really bleeding at this moment. And the funny thing about that, this new cut down, they call a new focus KADK. So we start thinking, were we unfocused before, or how was this? But yeah, but this is what we are dealing with at this moment. So what I'm trying to say is that when we talk about the curriculum, the main contents of the education and the programs are still there, but we have practical challenges on a daily basis to sort of to reach new understanding of how this is going to be taught. But so far we know that the program we have been running the past 2 years is still running. So this is the present situation. Well, as for this, which is now running, we were asked to include research and also having a closer contact to the profession as part of this new structure. And in that sense, from a managerial point of view, they considered CNARC, which was the research center, and this new candidate program to be this new setting for the student environment. And CNARC is, as I mentioned, has lived for about 12 years, and we engage in all different kinds of projects. We have a lot of PhD projects going on with industry. We have a special program in Denmark called the Industrial PhD Program we can apply for, but also other companies and regular fully academic PhDs are part of this project. And we have been doing a lot of dissemination and events like this, similar to this, where we also try to engage and invite people from the profession and from the industry to take part in similar discussions, but very much focusing on the fabrication or the manufacturing of architecture. And we do a lot of publications, and some of them I brought with me here for you to keep. Some of them are in English and some of them in Danish. But this is actually telling about the candidate program, and this is the anniversary book about CNARC, which came out last year. Please. But also, as for the program itself, we are collaborating with cities and counties in that sense that we take up problems or ideas or politics. Actually, they're trying to push forward and engage the student projects in these collaborations. This is from an exhibition we had last year in a large paper mill that is a huge area in the city of Næstved that has closed down, and in an industrial area where the students worked within in that context, and the projects were then exhibited in the mill. And there was a whole group of people from the city hall and regular inhabitants of the city who participated. Please change. And this is just to show how the semester has been is structured. It's very simple, but we usually have a portfolio week where everyone presents. We also go to Switzerland, but this year the first year we went to Venice. Then we have a huge bulk of collective data. We have the students make different sort of registrations, interviews, and whatnot, and then we have this pool of data which everyone can draw upon in their projects, and then they do their individual projects, and then from that they take the last 4 weeks. They take out a specific aspect they deal with in greater detail. Please. And this is just to show some of the seminars we have in the beginning, where we had the first year we have a yearly theme, where in this case we had the first year we had metabolism, constructing strategies for reuse. Last year we had atmosphere and critical regionalism, and this year we have resilience and re-industrialization. So we always try to have a meta theme and a more sort of specific study object for the students to sort of frame their projects. And in this case, where we were talking about metabolism, we had a group of people across, people from the news world, philosophers, and also people from Rota here, Martin Gehlen, your colleague, and yeah, to bring up sort of like, or to frame the discussions. But please. But as for the things I wanted to talk about, I think what is important, also having listened to the other presentations, is that I want to situate the examples and the discussion on which we sort of have built our program, these are the questions: why do we need to think architecture reconstructed? With this, and which is the first part. I'll try to sort of frame the overall question, and that will summarize also some of the different points that have been addressed in the former presentations. So this is sort of like the big picture of the environmental challenges in the building industry, and also sort of how to position how this affects architecture and the education of architects. And then this call for new design principles. I'll show an example from one of our PhD students who also, he's actually running an architectural office, and also teaching in our program. And finally, some examples from the students, how to design for life cycle, which shows examples of how to teach the field of salvage, in this case building materials in construction, and life cycle scenarios in the architectural design phases. Please change. But before digging into these matters, I'd like to open with a statement addressing the tectonic thinking, which is very much what I have been dealing with throughout my academic career, and also address in the teaching. And it goes for this: that tectonic thinking, defined as a vital attention towards the nature, the properties, and the application of building materials and the structural principles of construction, and how this attention forms a creative force in building construction through architectural design, that is construing, enables to identify, refine, and direct architectural strategies for sustainable building culture. So this is sort of the basic sentiment or idea. But as for the first question, why the need to rethink architecture reconstructed, that is a photo of one of the last fall or winter storms we had in Denmark. Last year it was called Bodil. They always have these female or male names now. And this is the harbor of Esbjerg on the west coast that was totally flooded, and this now happens on a yearly basis. But due to the growing impact of the climate changes and the predictions of the natural resource scarcity, it seems necessary to reconsider the basis on which architecture is conceived and being built, and how we ensure a proper framework for creating a holistic, sustainable architecture that supports societal prosperity. No, please keep it a little bit. And cultural diversity without compromising the living systems of the earth, and by what means do we achieve building cultures that are more robust in view of the future resource perspectives. In the years to come, these questions will be part of political decision making and will undoubtedly affect architecture and the construction industry. So therefore, in my opinion, teaching sustainability is not about attitude. I really did have a problem when I heard that the first time, because like, is it something you can sort of choose to address or to consider or not? No, it's about facing the true state of the world. It's about getting real, or to get real. As architects, we simply need to take on our responsibility and to use special skills and our special skills and come up with suitable answers to our growing environmental problems. Please. And here's some of the numbers. As for the global CO2 challenge, according to the UN Environment Programme, the building sector contributes up to 30% of the global annual greenhouse gas emissions and consumes up to 40% of all energy. And given the huge growth in new construction in economies in transition and the inefficiencies of existing building stock worldwide, if nothing is done, it's foreseen that greenhouse gases emissions from buildings will more than double in the next 20 years. And therefore the building sector must be considered as part of the solution if targets for reducing greenhouse gases are to be met or just considered more seriously. Please change. And this also points at this one-eyed insulation strategy, at least how we have seen it in Denmark. In Europe, the construction and operation of buildings are responsible for 36% of the total energy consumption, and the political objective is to reduce the use of energy by 20% by 2020. In Denmark, that they are already considering the fact that they're not able to reach these numbers, so they are now trying to open up the legislation for alternatives, which is, of course, questionable. But reaching this goal places high demands on the construction industry and existing buildings, and so far actions have focused on reducing the energy consumption through increasing insulation standards, as we see here, asking for airtight constructions, and by integrating green technologies, aiming at energy levels comparable to passive house standards. Presently, we see construction solutions designed where excessive amounts of insulation material are being used, obstructing good construction solutions and traditional building techniques. And as you may know that in Denmark and many of the northern European countries, we have a lot of brick, and having these insulation standards really puts a pressure on what you could say the mineral based constructions. It also counts for concrete constructions. Please change. So another important aspect to take into consideration when we succeed to minimize greenhouse gas emissions in our buildings is that the affecting causes shift from the operations such as heating and energy to the physical construction. In that sense, the embedded energy of the construction materials and building elements become very important, not only in regard of reducing greenhouse gas emissions when designing new buildings, but also when we take the existing materials and highly finished building components that have been going through a lot of processing into account for further use of recycling. How the affecting causes changes shows in this chart, showing the impact of the regulation of sustainable homes in the UK. And here you see how this little blue part, which actually points at the energy used for the construction materials and the processing. Now, when we reach the passive house standards or something equivalent to that, actually counts for the largest amount or leaves the largest CO2 footprint. However, I'm sort of doubting that the fact that it's actually so little. I think it's so much more, depending on how much you include in the calculation. Please change. So in 2005, actually, the European Commission proposed a strategy on the sustainable use of natural resources in Europe. And this strategy focused on reducing the environmental impact of production and aims to examine the whole life cycle of our natural resources, how natural resources enter our economy, what products are made from them, and at the end of their useful life, how the various materials and substances return to soil, air, and water. And the intention is to point to solutions such as cleaner technologies and environmentally less problematic substitutes. In other words, to avoid resolving one problem while creating another. The resources strategy is interesting because it offers a broader perspective than the pure energy focus by including a diverse range of parameters, also defined as life cycle thinking, here shown in the relation to building. And this, of course, may be common sense for most of you, but I still think this is, when we present this to people in the construction industry, they're always sort of not, but when you sort of look them over the shoulder, you realize that they're not there at all, getting not even close to this way of thinking. Please. But what about waste? This life cycle thinking relates to the question of waste, and the Danish government presented in 2013 a resource strategy named Denmark Without Waste. The strategy describes how Denmark must recycle more waste and reduce waste burn in incendiary plants. We just saw this huge incendiary plant presented by you yesterday, designed by BIG in Copenhagen. It's already has become a big political issue because some politicians want more waste salvaged or reused, and of course the company who owns the incendiary plant wants more waste to be burned. So now they're actually considering importing waste in order to have it running. So the largest part of Denmark's total waste comes from demolished buildings, and in 2013 the waste amounted to 2.6 million tons per year. A total of 87% of construction waste is recycled, primarily being crushed for road fill. However, this sort of recycling is not particularly sustainable considering the loss of embedded energy or value of the materials and products. Also, harmful substances are released into the environment with risk of polluting. A better way of recycling is to reuse materials and elements without substantial processing. It will provide a better energy balance, and historical building elements can be salvaged and including in a sort of cultural cycle. Please. In regard of the various questions raised, it's important to note that most of the prior definitions of tectonics or making of buildings have responded to profoundly different and much less complex circumstances compared to the building industry we know of today, both in terms of materials used, craft traditions, and the evolutionary stage of construction techniques. Present-day construction industry involves a multitude of natural, artificial, and composite materials, highly complex construction designs, and industrialized building supply chains. Today, architectural design phases are closely linked to industrialized manufacturing and the rationality of the construction phases. Please change it. And as for the cultural diversity, it also demands for data and control over local climate conditions, performance of buildings and physics, and management of energy consumption are equally influencing the evolutionary course of the construction industry through unification of building standards and regulations. And today, construction industry has developed into a paradox of autonomous but interdependent systems, largely ruled by global trends and economies. Within this context, regional cultural identities and holistic approaches to construction as part of the architectural design are difficult to maintain, and in worst case scenarios it results in careless collage architecture that no longer depend on local materials, craft traditions, or cultural values. Please change. So this points towards what we call an ecology of tectonics. In view of these the diverse character of environmental challenges, the CO2 discourse seems critical as it does not suggest a comprehensive or ecological perspective, despite the many good intentions and measurable effects that are linked to reducing fossil energy consumption. This environmentally friendly action happens to have adverse implications for the architectural design. How do we use the material resources, and how can the architectural design respond to a larger degree of complexity that comprises a cultural or ethical dimension in construction? These questions call for an ecological approach, defined in its widest sense, which includes environmental dimensions, life cycle of natural resources, robustness of social organization, cultural diversity, and longevity of the architectural design. Thus, rethinking architectural construction in the age of environmental crisis means to rethink architecture as reconstructible, or to think forward by designing backwards. And this leads to my second statement. Please. Where we claim that an ecology of tectonics holds the concept of buildings as parts tied together as a whole in a broader context of natural and cultural systems. This understanding feeds into a new ethical dimension, into a tectonic practice that recognizes the correlation between the materials used, the ecosystems they form part of, and the resources we share as common members of the global community. To use this understanding as a guiding principle in the design and construction of architecture seems crucial in view of the environmental crisis we're facing today. Please change. And this is an example from this PhD project that has been carried on in Sinar by Søren Nielsen. and it's a recent it's an attempt in which he tried to define construction principles for reuse as part of a tectonic design strategy in his project Adaptability as a Tectonic Strategy. And Søren Nielsen is partner of the Danish architectural company Vandkunsten Architects, and has been doing his PhD for 3 years. Haven't finished his dissertation yet, unfortunately, but has been writing several articles and also made demonstration projects. Please. He explains that in these technical diagrams, which he has been developing across a number of projects within the firm, he has been analyzing how the resource flow has been and how the construction actually is situated. And he explains it like this: in technical diagrams, a building, its parts and details can be dissolved into a number of separate variables that hold a general relevance for all similar operations. The diagram documents programmatic results, but reveals nothing about the tectonic articulation. And what he also has found out, which also has been stated by the company Pure Timberlake, who's been dealing with similar issues, is that the procedure in which you design and how materials and structures are being constructed is fairly different from when you actually have to dismantle it. But please change. But this technical diagram is linked to this tectonic alphabet, as he calls it. So these are sort of like two different representations or articulations of the same problem or the same aspect in construction. And as for the tectonic articulations, they can be identified as form-generating phenomena, which can be shown in pictograms. The very link between the technical principles and the tectonic articulation remains situated in the material evidence of the actual building. The pictograms have developed into a whole alphabet that can be organized in groups of tectonic typologies or as generic families. And this has also shown very helpful when we're trying to translate some of these more technical principles to the students, because it's a different mindset, it's a different way to look upon the same construction principle. Please change. So this he has also used here in a specific analysis of this project, which he has used this both for analyzing existing building which they had designed, but also having used it for defining or expanding the program in competition briefs, and it has showed in both cases to be very helpful. But this is actually the way he defines the different levels of the similar design features of the construction. Yes, please change. So, as for teaching sustainability within the candidate program, we have at this moment two different levels or main initiatives. The one was, as I explained before, was the theme of the year, which this year, not this year, this is an old year. Well, anyhow, connected to these publications, metabolism and strategies for reconstruction, and the second part is what we call a research practice linked to research projects within the research center, where we as researchers do have a regular research project with a number of companies and other institutions, the Technical University in Denmark, and then we include the students where they are part of an intern in selected companies who also work within the similar in the similar field, and they also become the projects are being disseminated within these publications that I also brought here today. Please change. But this is an example of the yearly theme, where we had the students first make a thorough analysis together with a number of demolition companies, where in Greater Copenhagen there was places or quarters of the city where there was a great change of resources or a high metabolism in terms of construction materials. And in that way they found, or they mapped and pointed out specific areas in the city where they wanted to work, or they should work. So this was the sort of the initial engagement in this project, and the students worked together for a week and a half with the demolition companies on site, and also interviewed the companies. Please change. And as part of this initial task, they also went through, made these sort of schematic registrations of the different materials in terms of, this is about the exterior walls, I mean the different sort of materials, and at what, how many amounts of the different fractions and so forth. And also they had historical studies into that particular building technology or construction technique as a parallel study. Please change. And then they worked on this overall amount of data they developed in terms of these different hierarchies of where to what level was the building component processed, and also having it discussed in terms of literature and different theories, among others, Stuart Brand's How Buildings Learn, and his theory about sharing layers, where you have to consider which part of the construction has to be taken out in order to maintain another part of the construction and so forth. So it's a very much more complex way of thinking of the different layers of construction, rather than just when you look at a section it looks somewhat easy to grasp, but actually when you include his theories, it becomes much more dynamic and much more complex. Please change. And this is some of the outcomes from this. Some of these students who one group, we have them work in groups or encourage them to work in groups. We cannot force them, and now we've come to a stage where most of them do work in small collaborative groups of usually of 2 or 3 people, and this group worked on the old brewery, Carlsberg Brewery, in the center of Copenhagen, which is now being totally transformed. There's a lot of very, very beautiful buildings, and some of them are luckily listed, but many of them also from the 80s and late 70s haven't been listed. And this is one of them. It's the big bottling facility where they used to bottle the beer, which is from the early 80s. A very, very nice building made of fantastic materials and a beautiful structure. It's one of the largest free-span structures in the center of Copenhagen, and it's actually planned to be taken down. But the students made this LCA analysis together with. At that point, we had also in this particular project we had. A course, a 2 weeks course, parallel course with students from engineering students from DTU, who helped our students, or worked together with our students on LCA analysis. And the students here came up with the fact that it would only cost the energy consumption of one similar, or what they call a comparable unit or building. Rather, if you kept the structure and had it transformed into new or different programs and use, whereas if you tore it down and had to process all the waste, the construction waste, and had to re-erect a new building, that would be the CO2 emission of that feature. So what the student did or proposed was to keep the structure and to add different new programs where you could actually use much of the structure as it is, but for new purposes. It would be a covered marketplace, and also having student housing on the side and exhibition spaces, and for that it was a pretty feasible result coming up from this project. Please. This is another project from another group of students who worked with in an urban area of social housing, where we have these prefabricated concrete element structures of the 70s that are very, very difficult to refurbish and also to reuse. But they, from that point, they developed an alternative concrete element that could be disassembled. So they spent a lot of time working on the very joints between the elements and how they actually could be assembled and disassembled, and also be configured into different spectral sizes, and in order to add flexibility to this structural system. So by studying existing concrete prefab structures, they developed this new building system. Please. And this is what we call the research intern project, where we had students affiliated with two different companies, Van Kunsten, which I just mentioned, and Linear Group Architects is another company. And what is particular about these two companies is that they both are very much engaged in projects that are based on ideas about circular economy, but from different perspectives. Whereas Van Kunsten is much into what I just explained or showed before, the design principles, how to develop design principles, whereas as Linear Architects are more so into what they call work together with industry, feasible market or business models for recycling materials. And in this case, they actually they take concrete waste, crush it, and re-implement it into new concrete structures. Please. So this is from one of the Van Kunsten projects, which they did also together across a group of Nordic universities and other companies. It's called Nordic Build, where they look into this component reuse and prototyping, and they have come up with a fairly large catalog of different ideas. In this case, they are using these spiral ducts, and they flatten them out and reuse them for cladding. And this is just a rendering from one of their existing houses where they're testing it. But they made a whole series of different prototypes. Please. This is the students' work. They were working with the company inside the company for 3 months, not working on their projects, but having developed their own project, but leaning or borrowing ideas and theories from this particular design principle, and developed this prefabricated system for local recycling centers in Copenhagen. And what was particular about this group of 3 girls was actually they were communicating with the city of Copenhagen, and the Office of Waste Handling, and actually they came up with a proper project which could actually be developed in case the city of Copenhagen wanted to go further with it. Please. This is the other project of Linear Architects, who, as I said, have been very much into this whole business model of how to recycle concrete, not only for road fill, but also for new structures. And they have, together with this self-storage company, Pelican Self-Storage, they have developed now a building system, which they're now testing in the center of Copenhagen. Please. And as for the students, they got involved more directly in that particular project and developed these new concrete columns that can be dismantled after use. There's a big thing about handling because they're huge structures or huge building elements. They're not easy to move around. But what's important is that you can actually take them down and use them again, in this case for this self-storage system. And they did, you can't see it here, but they did thorough calculation and comparisons between regular construction systems and these particular new structures. And this is the concluding statements, which is maybe a little bit, who said spiritual or ideological, whatever. I don't mind to moralize a little bit, but to think architecture design for reconstruction includes an ecology of tectonics that brings a new ethical dimension into architectural design and the construction industry. And it offers a series of holistic life cycle strategies that open up for alternative markets and a new role of the architect. And it sparks ideas for new architectural design principles based on structured and transparent methodologies to be shared across disciplines. These are the concluding, I wouldn't call them findings, but these are just ideas about how to further develop these different principles. I think from the tectonic point of view, which I have very much engaged with, I do believe that coming from a different perspective than the urban perspective we listened to yesterday, I think there are similar, I should say, overall engaging dimensions that can have just as important and direct effect into a larger perspective and a global discussion. And therefore I also think from a student perspective it's very, very interesting because you can come very quickly into a direct dialogue with industry, architectural companies and colleagues and make proper experiments and so forth. So in that sense I find the tectonic discourse very productive and very inspiring. And this is, you can turn to the last one. Yeah, this is one of the final examples of one of our graduate students who cut up concrete elements and made them into these propositions for slabs, what's it called? Freezer, pavings. Yeah. This is it.